Combination of rules. Some composite functions require more than one application of the chain rule in order to find the derivative. For example, consider the function y equals sine cubed 2x plus 1. To find dy dx, we start by identifying the function as a power, i.e. y equals sine 2x plus 1 all to the power of 3. Then, using the chain rule, dy dx equals 3 sine 2x plus 1 squared. So we're differentiating the power, we're bringing the power down in front, reducing the power by 1. And then we're differentiating the inside, or differentiating the base. So we do differentiate sine 2x plus 1 with respect to x. But the base itself is a composite function. So the sine 2x plus 1, this itself is a composite function. And it's in the form of sine u. So we will have to use the chain rule again. So dy dx is equal to 3 sine squared 2x plus 1, which is what we had already worked out up here, multiplied by cos 2x plus 1 times 2. So we're differentiating now the base, or the inside. So the derivative of sine is cos, we keep the angle, and the derivative of 2x is 2. And next we simplify. 3 multiplied by 2 is 6, so that's where the 6 comes from. Sine squared 2x plus 1, and then we just stick on the cos 2x plus 1. So here we have the derivative. So what we did was we applied the chain rule twice. Find dy dx if y is equal to x squared sine 2x. So x squared sine 2x can be written as x squared multiplied by sine 2x. So x squared is our u, sine 2x is our v. It is essential to recognize this as the product, which means multiply, of x squared and sine 2x. Because the angle is 2x, we will need the chain rule to differentiate sine 2x. So y equals x squared sine 2x. The u is equal to x squared, and the v is equal to sine 2x. So we differentiate u with respect to x, so the derivative of x squared is 2x. And now we want to differentiate v with respect to x. So the derivative of sine 2x is going to be cos 2x times 2, which is 2 cos 2x. So to differentiate sine 2x, we differentiate the trig function. So differentiating sine gives us cos. We keep the angle, so the 2x stays the same, and we multiply that by the derivative of the angle. So the derivative of 2x is 2. So this simplifies to 2 cos 2x. Now we have everything we need. We input our values into the product rule formula from our formula book. So here is our product rule. dy dx equals u multiplied by dv dx plus v multiplied by du dx. So u is x squared, dv dx is 2 cos 2x, plus v, which is sine 2x, multiplied by du dx, which is 2x. X squared multiplied by 2 cos 2x is 2x squared cos 2x. And sine 2x times 2x is 2x sine 2x. Let's have a look at another example. If y is equal to the square root of x plus 1 divided by x minus 1, show that dy dx is equal to minus 1 over x plus 1 to the power of a half multiplied by x minus 1 to the power of 3 over 2. So the first thing we want to do is rewrite the square root of x plus 1 over x minus 1 as x plus 1 over x minus 1 to the power of a half. So the root becomes the power of a half. So step 1, we're going to apply the chain rule. To differentiate this, we start by using the chain rule to differentiate the power. Then we use the quotient rule to differentiate the base. We will have to use algebra to tidy up the answer. So if y is equal to x plus 1 over x minus 1 to the power of a half, then dy dx is going to be a half times x plus 1 over x minus 1 to the power of minus a half. And that's going to be multiplied by x minus 1 times 1 minus x plus 1 times 1 over x minus 1 squared. So let's have a look at this. So this is the outside, or the power. So we bring the half down in front, and we reduce the power by 1. A half minus 1 is minus a half. Next we differentiate the inside, so x plus 1 over x minus 1. So we have to use the quotient rule for this. So we know the quotient rule is v du dx minus u dv dx all over v squared. So the top of our fraction is always u and the bottom of our fraction is v. So we have v multiplied by du dx, the derivative of u is going to be 1, minus u, which is just x plus 1, multiplied by dv dx, the derivative of x, again, is 1. And that's all divided by v squared, so x minus 1 squared. So to differentiate this, we must use the chain rule. But in order to differentiate the inside, or the base, we have to use the quotient rule. So now we need to tidy things up using algebra. So a half times x plus 1 over x minus 1 to the power of minus a half. Well, the power of minus a half can be applied to the numerator and the denominator. So it becomes a half times x plus 1 to the power of a minus a half over x minus 1, again to the power of minus a half. So we're basically applying the power to the numerator and the denominator. So we're using this rule here. So a over b to the power of n is equal to a to the power of n over b to the power of n. And then tidying up the right hand side, x times 1 is x, minus times x is minus x, times 1 again is minus x, so they will cancel. X minus x cancels. Minus 1 by 1 is minus 1. Minus by 1 is minus 1, so we end up with minus 2 in our numerator. We still have x minus 1 squared as our denominator. So now we have some more tidying up to do. Well, a half multiplied by minus 2 gives us minus 1. So that's where that minus 1 comes from. And x plus 1 to the power of minus a half, we can rewrite. So a to the power of minus a half gives us 1 over a to the power of positive a half. So x plus 1 to the power of minus a half, we can rewrite as 1 over x plus 1 to the power of positive a half. And the rest stays the same. So we have minus 1 over x plus 1 to the power of a half, multiplied by x minus 1 to the power of minus a half, multiplied by x minus 1 squared. So for this part here, highlighted in blue, we're going to use the fact that a to the power of minus a half multiplied by a squared is equal to a to the power of minus a half plus 2, which is equal to a to the power of 3 over 2. So multiplying powers by the same base, we add the powers. So minus a half plus 2 gives us 3 over 2. So we end up with x minus 1 to the power of 3 over 2, because minus a half plus 2 is 3 over 2, and everything else stays the same. And here we have what we were asked to show. So we've shown that dy dx is equal to minus 1 over x plus 1 to the power of a half times x minus 1 to the power of 3 over 2.